Good morning all and welcome to today's webinar. My name is T. Baroni, business psychologist for Mech Solutions, and I'll be one of your hosts for today's webinar. Before we start, however, I would like to give a brief introduction of our company. So we're Mech Solutions. We're basically a construction tech consultancy based in Bahrain, and we specialize in software solutions and organization development. So basically, in a nutshell, what we do, we go into construction companies, consultants, and we help them to achieve their strategic goals by improving company performance. You can visit us at www.meccss.com for more information. Before moving on with the webinar, we'd like to give a big thank you to our colleagues at Gloden. So here today we've got Mr. Nazrul Farik, business expert, and Mr. Xavier Wang, channel manager. So we'd really like to have thank them for collaborating with us on this webinar. And last but not least, we'd like to give you, the audience, a really big thank you for participating today. We hope you enjoy the material and find it beneficial. So for today's webinar, it's entitled The New Norm, from 2D to 5D BIM measurements with Cubicost. The webinar will take approximately 1 hour and 45 minutes. In terms of presenters, from on the Gloden side, we have Mr. Nazrul Farik from the Malaysian office and Mr. Xavier Wang, also from the Malaysian office. Here from Mech Solutions, we've got engineer Samim Laskia, our technical consultant. So next up is Mr. Nazrul. So he's going to give us a brief look or a quick view into, what digital building is and the construction industry's transformation into the digital world. So without further ado, I'd like to pass it over to Mr. Nazrul.
Hello, good day everyone. I'm Nazirul Farid, Principal Business Expert of Gloden. I'm really glad to be here to deliver a brief content entitled The New Norm, Transformation Towards Digital Building. So this will be the fundamental knowledge in understanding what is a digital building. In my part, I'll be segregating into 3 categories, right? Digital building, the second one would be Gloden's digitization framework, and finally some brief on a case study, right? So digital transformation. So before we get deeper to this topic, let's learn how the transformation happened in other industries. So in the entertainment industry has quite a change for the past 5 years. So the social media, like Facebook, has turned into entertainment platform. So people go there for live streaming. So the way we listen to music also is so different now. Meanwhile, in automotive, most automakers they want to build a new ecosystem based on the electric powertrain. So instead of all, now they try to build more powerful and fast charging batteries. So company like Toyota, they want to create their new OS to create an in-car app store. Meanwhile, company like Fiat, they're working with Google due to the tight development budget. So everyone's have their own strategy, but they are still finding that digital transformation is very important, right? So if you can see, in the construction industry is not doing so good, so it still continue operating as it has for the past 50 years with a heavy reliance on the manual labor, mechanical technology, and some old business models. So what we've seen in the current ecosystem of the construction project, from the inception stage towards to the close out, these are the 2 stages that are critical: the design and tendering phase, and also the construction stage, right? Digital building is needed because at the design and the construction phase, we have been taking so much time and we are still in the traditional method. So these are parts that desperately need to be transformed. So now moving on to what's digital building. in digital building is the use and the application of digital tools, leveraging from the technology such as building information modeling, BIM, big data, Internet of Things, artificial intelligence, and more. This is where we can improve the process of delivering and operating in the built environment. In general terms, that will translate into making the delivery, the operations, and renewal of our built environment more safer and more efficient and more collaborative. So it will ensure that that we get a better outcome at every stage of an asset's life cycle. And now we're moving on to the Golden Digitization Framework. So this is a very important part as we try to share with our stakeholders, right, on what we have been doing in Golden. So this Golden framework is a guideline for us to adopt a digital transformation and moving on to the digital building. Okay, this is the framework. Right? As you can see here, this is a conventional way of the production change, and it consists of three macros: that application of efficiency of traditional human, machine, heavy equipment, and material resources can be significantly improved. Meanwhile, on the all processes, digital building guarantee the optimization and the feasibility of all process from the design, construction, and finally on the maintenance plans, right? And all processes, the all participants, we focusing on the digital building, facilitate participants, the government, the private sector, all parties in improvement of project operation, management, and services. So these are the parts, the three macros. It has to be decomposed. We have to try to redefine these three things, right? And how we can do that. So I'll go through with you on how we go through and how we can compose it, right? After we decompose and we compose it into the three drivers: digitization, the connection, intelligence, right? So in digitization, we creating a digital version of analog information, such as from the conventional way of the checklist, the drawings, into a digital form that can be accessed through a mobile device, computer, instead of just a paper. And in terms of the connection, the smart connectivity that communicate between the smart devices seamlessly, that also capable to transfer data over a network. So the connection here is very important, right? And moving on to the intelligence is how this driver is capable to simulate the human intelligence in a computer or a machines that are programmed to think and mimic the actions like human. So these three drivers have to be embedded with the three elements that three macros that I've mentioned earlier. Okay. So at the end of the day, when it comes to the new design, when it comes to design, we able to redefine the new design on how we can adopt a new way of doing things. Okay, so the pure digital sample stage is the complete process for digital simulation of the life cycle of the building. So before starting construction, all parties can use BIM model to participate in all project design. During the simulation stage, all parties will make the overall simulation of the project purchase, construction, and maintenance, and the core questions that may occur during the construction and maintenance procedures will be moved early for demonstration. So it is a stage that digital building will be performed and optimized for the higher efficiency and time and financial cost, in terms of the rework rates and the mismatch rates can be reduced. So it creates plan, do, check, and act closed loop with the least cost and the fastest speed. So it can preset a control measure to meet the management and product individualized needs, improve the reasonability and feasibility of plans, and a guarantee to high usability of the products. So this is what we aim for the new design. Okay. And then when it comes to the new construction stage, this part will be divided into two. The first one is industrial manufacturing based on a plant integrity, and the second one is a cyber physical system based on intelligent construction site. So these two will be combined. Okay, so industrial manufacturing based on a plant integrity, we are talking about how we build the precast, how we really adopt the prefabrications, digital printing in a more controlled environment, so that we have a zero distance project communications. We can avoid a delay of site workers. You can have a zero idleness of equipment, waste of site materials, defects of project quality, accident, obstacles of works progress. So this is like how we build a car, right? It's more in a controlled environment, something that the task packages that can be automatically arranged in accordance with the intelligence algorithm distributed to work in units accordance with the programming sequence and very restrict conditions. Okay, and when these things has been completed, it will deliver to the site, so the site will become more intelligent. Okay, so it's like the construction site now is not something that are full with a lot of works there, a lot of processes, a lot of let's say we're talking about a rebar cutting, we could have a lot of wastages over there, and we can have a lot of high risk, such as flood, such as a thief, right, and many other risks that may occur on site. So we try to change that into more intelligent construction site that can form a big data through intelligent devices. Okay, and effectively integrate and systematically adjust and accumulate. So product materials also, when it reach to the site, it can be detected. Okay, so there are things that being coming in and coming out in a more controlled environment, right? And finally, on how we redefine the maintenance. Okay, and the new maintenance is talking about a self-adaptable intelligent asset. Okay, from low service efficiency, it comes to the high energy consumptions, low environmental efforts, high waste of building assets. Okay, we can transform all of these to more perceptible, analyzable, and controllable, also self-adaptable. So imagine yourself like being in a building. You don't need like a remote aircon to control the temperature anymore. It will self-adapt, all right, with the with situation. It will detect the heat load of the devices in the building, the how many people inside the building. So it will self-adaptable, right? And everything is AI driven by big data to do intelligent judgment for self-optimization, self-management, and self-maintenance. All right. So when it comes to the maintenance, when it comes to necessary adjustments, some signals will appear for us to react instead of we try to find out things in manual way. So at the end of the day, it able to offer a comfort and health services to improve and satisfy our living needs. Okay, so some brief case study here. We've seen in Singapore, there's a integrated digital delivery that they being used in their built environment. Okay, is the use of the digital technologies to integrate work processes and connect stakeholders. So this is the thing that is actually, if you focus, it is something similar that as what we are doing in Cloden. Okay, they will have a digital design, okay, digital asset delivery and management, digital fabrication, digital construction. So it's almost same like how we are doing it in Cloden. Okay, digital designs like involvement of software that able to communicate among each other. So project teams, they are not working in silos anymore. Okay, and the digital fabrications, we talking same like how we have in Claudine talking about a new way, the manufacturing in plant-based environment. Okay, and digital asset delivery and management, we talking about the new maintenance. and digital constructions. Also, we're talking about the cyber physical system in a construction site. Okay, so it's almost similar with and how Singapore been doing it. Okay, with these four main components, it will help us to move on, and we can redefine the construction industry. And one of their players, okay, is the Subana Jurong, a consultancy company. They are focusing on the infrastructure and urban development. So Subana Jurong has achieved the international standard ISO 19650 accreditation for the digitization of design and engineering data for buildings and civil engineering works. That includes the building information modeling. So in their frameworks, they also focus on the digital design and the construction. So they use the monitoring and inspection projects using the cameras, drones, and they also have a live asset monitoring and a contractor movements. That one is to focus on the productivity. Okay, we want things running smoothly and efficiently, and they're able to perform analytics and productivity studies, and how they doing it, and they manage their design and information using BIM. Okay, so this is something that we all have to adopt. And of course, we are maybe finding it difficult with doing it alone. So in digital asset delivery and manufacturing also, they are also focused on the collaboration. Okay, they collaborate with a strategic partner, and we in Global are lucky to be one of their partner, right, for the focusing on a BIM 5D. Okay, and not to forget in terms of the community and for the coming generations, so they are also focused on the education and sustainable growth, right, through Subana Jurong Academy, that focusing on developing the digital skills, so everyone can adopt the digital skills and have that digital mindset. Okay, so with this example, it gives us some insights on how we can do in within the organizations and moving on towards the community, so that the built environments will improve from what it is today, and for coming generations, they will enjoy the benefits of that, right? So to summarize my contents, right, the organization's process and the managements are really highly influenced. Okay, it's really highly influenced by the strong leaderships. So this is something that we have to look for, and we have to understand the three macros and the three drivers that I mentioned earlier in Global digitization frameworks, though that will make us understand on how the transformation journey can be better. And also it aligns to the industry, national and a global agenda to promote sustainable and environmental friendly environment. So that, when we talk about the construction, it is not something that is dangerous, something that is high risk anymore. Okay, you try to change this environment and change this mindset for a better cause. So that is all from my session today. So we hope that really hope that I'll be able to share more. All right. Thank you.
Thank you, Mr. Nazarud, for that great presentation. So as we can see here, the construction industry is being dramatically transformed. No thanks to innovative technologies such as BIM, AI, VR, big data, IDD, and other technologies. So there's a lot to look forward to in the next coming years. Next up, we have our very own engineer Samim Laska. So Mr. Laska is going to look at Cubicost and how take a look at BIM-based measurement using the Cubicost platform. So I'll just pass it over to Mr. Laska now.
Good. Thank you very much for joining us. My name is Shamim Ahmed. I'm a technical consultant with Max Solutions. My part of presentation is technical demonstration of Cubicost software, where I'll be talking about automated takeoff from 2D drawings and BIM model. The whole point of what I want to discuss is about how BIM has evolved in quantity surveying over the last number of years, and show you how Cubicost could make it possible. So first thing I want to do is I want to take you through a BIM-based centralized quantity takeoff and estimation software, Cubicost. So what is Cubicost? So Cubicost is a suite of software that covers quantity takeoff for architecture and structure, what we call it as TAS, and then takeoff for rebar, which is TRB, and finally estimation and tender management software such as TBQ and eTender platform. So in today's presentation, we're going to look at TAS and TRB in particular. Just to have a better connection, I'll turn my camera off here.
Okay, so to start with, if we break down the name Cubicost, Cubic is the part where we talk about BIM-based quantity takeoff, and then cost represents BIM costing using TBQ for BOQ pricing. And then we have eTender platform. So for quantity takeoff, the software supports CAD files, vector PDF, or even scan PDF files. Also, I can import an IFC BIM model or a Revit model in the software, which could be a federated or a single model, and then straightway proceed with the quantification. What we got as an output is an interoperable 3D model with information associated with it or in it. And so I can obtain all the benefits of BIM as mentioned by previous speakers. So what makes it so unique is the fact that the calculations are in line with the measurements rules such as Principle of Measurement International, POMI, SMM7 and RM2 to name a few. The quantities that we obtain from the software can be linked to the BOQ bill items, and any changes that we make in the model itself would automatically update the total value of the project. In terms of measurement, the measurement is 4 times faster than traditional 2D and Excel measurement, and then checking quantities is also 10 times faster. And then based on our previous experience and client's feedback, the accuracy is worked out as 98.8%. Well, this particular slide shows the operation of the software. So we get quantities of elements and rebar from the TAS and TRB software, and then that quantities can be linked to TBQ for BOQ preparation. The good thing about the interconnected platform is that any changes that you make either in TAS or TRB would automatically change the BOQ. Okay. So what we can look at on this slide is the process or steps involved at different ways of doing the quantity takeoff. So in traditional way, we have got a few steps involved. So we read the drawing, then we go ahead with measuring length, tabulate the numbers, create formula and deductions, and finally we get the reports out of it. In 2D, however, if you are using a 2D software, then you read the drawing, you measure with the 2D software, and then create formula and deductions, and finally you produce the report out of it. However, if you have a 3D or BIM model or a BIM software, then the software would read the drawing and it would automatically build up the BIM model for you, and from there, using the all the calculation rules and computation expressions, the software would automatically generate reports out of it where we get all the quantities in place. So just to give you an overview of the workflow, so basically when we have a CAD drawing or a vector PDF, the software identifies all the elements from the drawing itself, and then it automatically builds up the BIM model. When we have a hard copy or a scanned PDF file, all we need to do is to define and trace the elements to generate the BIM model. And then if we have a BIM model already, a Revit or an IFC file, all we need to do is just import the file, check element properties, and then we can straightway proceed to the quantities by one click. And then different types of quantity reports can be produced out of the software, right? So, Okay, so again, this slide shows the view of interconnected platform. So the BIM model can be generated either in TAS or TRB, and then that can be linked to the VOQ using TBQ software for automatic updates of quantities, and that is directly from the BIM model. Also, we can use eTender platform for managing tender documents, which could be, the process could be like sending out inquiries, receiving quotations, evaluation of tenders, and so on. All right, so without further ado, let's get right into the project that we took up for this presentation. It's a small project for a quick testimony. So here are some details of the project. So this is a double-story residential bungalow with a pile footing, common clay brick wall, and an in-situ frame structure. It's just a simple structure to demonstrate the capability of Cubicost software. First off, let's start with an introduction of TAS and TRB, which will give you a good overview of how the system works. So here I'm going to play a video.
Just imagine, each of your projects could be automatically taken off. Each of your quantity reports could be intelligently generated. Each quantity of your BQ could be traced back to your source. Check is so easy and clear that you could view them directly without any redundant calculation. We present you Cubicost. With Cubicost, you could obtain dimensions on drawings intelligently and generate BIM models accordingly. You could possess multiple standard methods of measurement around the world. Through the combination of built-in measurement rules and 3D models, you could calculate the quantities automatically. Instead of repeated manual quantity takeoff, you could obtain the quantities rapidly with just a few steps. In addition, Cubicost provides present report formats that you use most frequently and fill data in them automatically. Thus, you no longer need to copy or compile the complicated Excel formulas. Meanwhile, you could customize the required report formats on your own. After you fill quantities in BQ, Cubicost could help you interconnect BQ, quantities, and BIM models. You could easily find out where each quantity item in BQ is from and where it goes. This is Cubicost Takeoff Solution, your intelligent, visual, and interconnected whole process takeoff solution.
All right, so I hope now we have a rough picture of TAS and TRB software. So now let's start our journey with takeoff software for architecture and structure, which is TAS. So we start with creating a project where we'll be looking at architecture and structural elements. So in here, we can start with creating a new project and type in the project name first, and then followed by selection of rules of measurement or the method of measurement, and then also we can choose the measurement units and ground elevation. So this is the initial setup that we do while initiating a project, and then we can straightway go ahead with some other settings, like setting up the measurement rules or measurement settings. So let's go ahead and look at some of the settings here. So we've got measurement settings here, which allow us to change and check different rules for different elements. So for instance, we are looking at wall, we have got different options here to you would be able to choose and change them based on what you require. So here's the thing. So now we have imported some 2D drawings just in here. So what we can do is we can split out or crop out the a drawing where we have got different plans, for instance, and then that would produce different drawings by separate names. So for instance, we are creating here different floors, and then from each of the drawings is splitting out to ground floor, first floor, roof floor, and upper floor. All right, so the first thing that we do is we set up the access grid. So again, it's very simple, just 3 simple steps. So we pick up the access grid, we pick up the label, and then we proceed with the auto identification. So that's how it is done, and it's pretty much straightforward. It's just one-time work for producing the access grid. So this is setting up the project, and we're going to look at now generating few of the elements. So let's start with the first element as column. So what we can do is we can again perform 3 simple steps. So we can pick side line of the column, and then we can pick the level of the column, and by auto identification option we get the columns in place. So we can swivel around, check if they are in the positions, and to give you the information that the software basically identifies the 2D lines, and then from there it builds up the 3D model based on the level information that you provided as a floor height while initiating the project. So now let's proceed with the next element, which is frame walls. So it's essentially again 3 simple steps. So what you're gonna do is you're gonna select the wall lines, and obviously you can choose which type of wall that you're selecting. So is it a masonry or concrete wall? And then you pick up the side line, and then we can proceed with picking up some openings, which would then let the software know, okay, there is some opening coming up there, so that gets under consideration. And then if we don't have any wall labels, we can skip that, and we can just proceed with auto identifications. So there it is. So we've got the wall in place now. Let's move on. As we have the wall in place, so we're going to proceed with creating some wall openings here. So for wall openings, there is one extra step, which is identification of elements schedule, or schedule of doors and windows. So what's so great about this function is that it pulls out data from your schedule, which could be an Excel file or a CAD file or a PDF file, and then that data gets fed into the model automatically for generating the openings. Right, so this is again pretty much simple steps. So you just identify the data from the CAD file or an Excel or a PDF file, and then you just make sure that all the data are in place, and just by one click identify, the software gets in all the information that was there in the schedule. Now there is one more step that needs to be performed just to create the opening. So all you need to do is just select the label, just to let the software know, okay, this label represents this type of window or door, and then there it is, the doors and windows are in place now. So it creates automatically that one as well. Now so far we looked at the vertical elements. Now let's proceed with some horizontal elements. Again, by 3 simple steps we can quickly identify elements like beam. So we start with beam. So again 3 simple steps, we got the beam there. For slab, again the similar thing. So you just pick up the level of the slab, which is the name and thickness, or it could be just the name, and then you can go ahead with identification of slab. And what the software does is that it gives you the option of typing in which type of, or which name or label represents what thickness. So you can type that in as well, or you can edit it at later stages. There is not an issue. So that is it for the beam and slab. Now let's proceed with the auto-generated frame results. So what we get is, after generating the beam model, is you have got the vertical elements, the horizontal elements in place, and that is just by 3 simple steps that we looked at just now. Okay. Now, so the next element we got here is lintel. So what happens is that there is a specific function using which we can automatically arrange lintels over non-concrete walls. Now here's the thing. So the software only arranges lintels over the non-concrete walls. So this function does our jobs a lot easier. So all you need to do is just input the size of the lintel, and then just select the drawing, and there it is. It just fits in automatically over the openings. So now let's talk about staircase. So in staircase, we do have a lot of calculations. So calculations like volume of concrete for the landing slab, length of the formwork and the edge and break of the landing slab. You have got then the volume of concrete for the flight, area of formwork for soffit and flight. You have got volume of concrete for flight, area of formwork for soffit for flight, and so on. So again, the length of handrail, length of nosing, all of these calculations. Now, how does the software deals with all of these different calculations? So we need to determine the quantities based on our 2D drawing. So what happens is that the software gives you multiple options, and it's pretty much simple and straightforward. So with staircase, all you need to do is input some dimensions such as the width of flight, depth of tread, height of riser, and then thickness of wedge slab, and width of landing, and so on. So as soon as you just typed in all of these informations, then you have got the access to model that particular staircase. So if you don't have those data in place, you can still do the quick measurement on the plan and find out, let's say, what's the width of flight. So things like that, you can just do 2D measurements, and then you can just start by clicking on that line, and then you proceed with the next line, and that's how it just automatically builds up the staircase for you. There is, however, a different way of doing the staircase. So you have got the preloaded some standard staircase shapes that can be used as well. Just you have to customize the informations like the data. But here's the thing. So in only 2 steps you got your staircase in place, whether it's a simple staircase or could be a complex shape as well. Okay, so let's move on. Now the next element is finishes. So we've got finishes next. Let's be honest, we do face a lot of problem in getting accurate quantities of different finishes. Using the software, you are able to build different shapes and get accurate quantities. So you can again input, or you can just identify the schedule of finishes directly from Excel or from CAD file, and that fits in automatically into the model. So what happens is that you can edit this format as soon as you identify. For instance, if we are looking at waterproof, there are some adjustments to be made or anything else that we need to make. So we just make sure that okay, it is getting the exact data that we had in the Excel format or in CAD format, and then all you need to do is just go ahead and identify that, and there it is. So the software identified all of these different finishes and already assigned to different rooms. Now all you need to do is just click on each room, and that's how the finishes are getting applied on those rooms. So as soon as you are done with that, you get a view of something like this. So you've got the wall finishes, the waterproof skirting, the floor finishes, and then ceiling finishes. If you have got a suspended ceiling, that is calculated as well. This is it about the superstructure. So we're going to move on with the substructure now. So in substructure, you can use the same 3 simple steps again. So for identifying footings, for instance, we generate pile caps here for this project. Right, so from this model we can auto-generate blinding or plain cement concrete and the excavation quantities automatically. So all you need to do is just create a blinding and just select the drawing, and this is it. The software automatically does that, and then you click on auto-generate excavation, and that's how it generates the excavation automatically again. You can do the adjustments in the top or bottom of these excavations based on your drawings or topographical map or control map data. Okay, so the next element is ramp. obviously, when we talk about ramp, it's like a special element. So we're going to look at how detailed the software can do the calculation. Now, sometimes it gets really hard to determine the circular curve shape going all the way up to different levels. Traditionally, sometimes as a QS, we tend to just measure the area and add some allowance on that quantity, which is not really accurate. So using the task in only 3 steps, you can actually build a ramp model. And that is right here. So the first step is to draw the ramp projections, okay, and in the 2D plan. And the next, we're going to pick up the center line of the ramp, and finally we can input the elevation or gradient, and there it is. So the software automatically builds up that 3D model for each floor as soon as you provide the accurate gradient or the elevation data. So the quantities that we obtain from this is something like you run the calculation, you get the quantities like volume, the area formwork for the soffit, area of formwork for the soffit strutting height, area formwork for the edge and break of the slab, and then you have got the projected area, weight of rebar, so on. Okay, so here's the model BIM. So we've got a specific function called align with different elements, and what it does is that it aligns different elements with ramp. So any element like wall or beam with the ramp can be aligned with the ramp and is very, very useful wherever it is required. Okay, so benefits of such ramp model are: we can draw ramp with 3 steps, simplest method available. We can then calculate ramp quantities more accurately than before. We can align different elements with ramp. That's again BIM-based ramp model, a smart solution. So that's how we get the quantities for ramp automatically, by building up the model. Okay, so now that is our model for the project, and that's ready kind of. We can go ahead and import this model into TRV for taking off the quantities for rebar. So rebar quantities could be for different elements, like structural elements. We have got column rebar first, so let's start with column. So there are multiple ways we can take off the rebar quantities. One of the way is to input the main bar and links in the standard formats available. So we can input all the main bars in a input format, and then we can input the links as well, and that would automatically arrange the rebars for column. Now, while you are putting the value, so you can visually see the arrangement, how it looks like, and it's fully editable. So you can draw a new link, you can do lettering, trim rebars, add some extra links, and so on. So that's really, really great when you want to visualize a particular model. Now, as soon as you run the calculation and then you would like to see the calculation results in 3D view, it shows you very detailed view of different types of rebars which are being used in that particular column. Now, once you're done with one column, that basically applies to each and every column that you have on the drawing for that particular type. But then again, you have got another option called synchronize, and using which you get you don't have to go through different setups. You can basically synchronize all this data to different columns in the model, so it automatically then arranges the rebar for remaining column types. Again, you can, like I said, just draw a link if that is required, and then you just run the calculation to get the quantities out of it. And here we can see that this particular column has got some extended rebars through the beam. So if there is a beam going down the column, then the software automatically extends the rebar, and it does calculate the the bending of that rebar and stuffs like that. So that's a really good tool there. You can visually look at the 3D model to see what is happening in the model. Okay, so let's move on. Now let's have a look at BIM now. So typically we get selection rebar or the selection of rebar, or the sectional rebar details are from a schedule rebar. So using the software, we can produce with identification of rebar from the schedule, and the software automatically fits in all the rebars. Now here we can see alternatively, we can identify rebar details from the sectional view of BIM as well. All I need to do is just go to the function called rebar layout, and then now in this window we can then pick up the rebar lines and the level of rebar, and just then the next step, the third step, is just to provide the range of that rebar from where to where it's going. And then similar thing we can do for the stirrups or links, and then we provide similarly the range where we want to put in the links. And then you get to this window where you can input some of the data, like the size of rebar that you're inputting, or you just check out the data which have been identified are correct or not. And then once that has been done, the software automatically arranges the links throughout the range that you just selected by dragging the line. So that's really automated steps. You just need to select these data from the 2D drawing, and the software automatically arranges all the different values in its place. Now if you would like to input some extra, or then you can go ahead and say, okay, custom link setting, and then you either draw a link or adjust another link, so that can be done automatically again. And that is how we then produce the BIM reinforcement. And as soon as you select that can be seen on the other screen in the model itself. So if you get back to the model and you run the calculation, you get to see that how many different shapes are being generated in the software for the BIM. And then if you would like to see the display setting, then you get to see for different BIM element the rebar, how did the software identify it from your original 2D drawing. So that's really detailed. Okay, so that was the check rebar by element. So we're gonna go ahead with the next element, which is wall rebar. So in wall, it's just a matter of vertical and horizontal distribution bar input. And then of course we can import all the hook details, and there is an intelligent function of software which allows us to apply the same rebar throughout the height of the building just by one click. So let's go ahead and just input some rebar information for vertical distribution bar, for horizontal distribution bar, and then we can copy and paste for all of these different cells, or just drag, and that's how the software just input all of this data for different walls. And then you get to see all the horizontal and vertical information as soon as you select that particular element, which in which you just arrange the vertical and horizontal rebar. So that's how we do the calculation for rebar. Let's go ahead with the next element, which is slab. So for slab, it's much more easier process. Actually, there are different approaches available. So let's look at auto range rebar function. So what it does is that it basically allows you to input the slab thicknesses range, and then it allows you to provide the bottom steel and the top steel rebar information in a input format. And then as soon as you are done with that, the software would basically identify all of these thicknesses slab available in the model, and then it would automatically arrange the rebar, the horizontal and vertical rebars, or the top and bottom rebars automatically in the model itself. Now, like I said, there are different ways of doing the rebar identification. So there is a rebar detections, which is automated. Again, this is something that we looked at before. The software identifies automatically, so you just pick up the rebar line and then you pick up the rebar level, which is the size of the rebar or the diameter of the rebar, and then you pick up the range of that particular rebar, how far it covers, and then the software automatically identifies all this rebar information. You just have to make sure, okay, the input format is correct, and then the software shows you in a beautiful format in a prompt out window that each of these identified rebars are listed there. So if you just click on that, it shows you directly into the model. Now if you run the calculation, then you get the detailed calculation for top and bottom bar, and then of different shapes can be seen right here. So if you just select that and then you get into the 3D view, you get to see that all the rebars are being arranged for all the different elements. So now more or less we're done with the major RCS elements. If we run the calculation, we get the 3D view of the calculated rebar shapes and the cut length of these rebars. This is how the 3D view of rebars look like. I mean, how precisely you can visualize the rebars is the key. So we can see different rebar diameters, the laps, bar bendings, spacing of stirrups, as we provided details for densified and non-densified spacing, for instance, for the BIM. All right, so here we are looking at foundation. So what we're going to look at is how the software applied to the rebar in foundation. So this again works for pretty much every element. So you can actually identify rebar information from a schedule, and what it does is that automatically fits in all of these different rebar data, and that is again can be edited from the view window where we see the rebar information, and then we can type in. So like I said, multiple options are available. You can either type in here, you can type in the properties, or you can identify from the schedule itself. And then this is how the software would get to know, okay, for this element I'm then inputting this rebar information. And then as soon as that is done, the software automatically fits in all of the rebars information. Just you need to select the element and right click for confirmation, and there it is. So the rebars are arranged for our pile caps here. So it's as simple, as straightforward as it is. Now the 3D view of the rebar with the required lap length and development length can be seen here. By doing so, what we obtain is that we get to see different rebar shapes with their details, and more details like bar bending schedules and what calculation formula is being used, which is really important to look at, and that gives you a quick overview, the visual view of how did probably the length or development length or lap length and then cut length, everything is been considered. So by doing so, if we click on one element, it shows the details, the shape of rebar in the bar bending schedule format. Okay. Now let's proceed with the results now. So we are quite closer to the end because we did the modeling for the rebar for the architecture and structural elements. Now here's the result. So just to recap, we built up the model in tasks which has required information in it and associated with it. Then we used the same model for rebar calculation, and the rebar arrangement or the skeleton looks like something like this one. Okay. Now it's time to get some reports or data out of the software. So let's proceed with that. So for architecture and structural elements, obviously using task software, we got the quantities of different elements. This can be customized, or used. It can be used for various purposes, and based on that, you can customize different data. So, like I said, you can set classification quantities on table format. You can turn on subtotal element range, filters, etc. For instance, we have one preloaded report format, which is for the calculation of this particular model, and that gives you this particular format. But again, you can set it as a template. You can use that template for different projects as well. So this is the subtotal that we are looking at, and then if we turn on and off different different classification of quantities, and that changes the format. And this is how we export and import the template. So that's the quantity report that we get out of the software. Now, okay. So now, if you look at the custom reports, so you have got the reports here, where you get to see the different report formats, and that basically, you know, gives you a detailed breakdown of quantities, how the calculations were taken place for different elements. For instance, the expressions of different computations. You have gotten the, you know, measurement worksheet for different elements. You have also the index summary analysis for different elements, so you can actually customize that. You can, you know, copy it to for another element, for instance, and then you can rename that. Let's say we are looking at, instead of wall, we are just doing beam here. So then you can you know, go ahead and say, okay, I would rather look at beam from the list, not the wall. So you just select the beam, and that basically, you know, takes all the data that have been calculated for the beam, and then that fits into the report. And then you can go ahead and say, okay, I do some adjustments there, and that's how it just fits in automatically. So that's really, really important. Now, to mention this, that the report can be directly exported into Excel, or you can print it out directly from here. So that's really great tool. You have got then the you know, worksheet for different other elements. And, you know, you can go on and on with as many elements as you wish. You can, you know, edit this data at any point of time. So that's really great. So this is like the customized reports from TAS. And then what we get from Rebar or from the TRB software is a detailed breakdown of, again, quantities. That's the first report. Diameter wise, you got the detailed breakdown of the quantities for different elements. And then you also get to see the you know, you can turn on subtotal if you wish to do that. You can customize and set classification conditions if you wanna, you know, set up some particular format. So all you can do is, we can, let's say, you know, providing a range of diameter where we want to see for this diameter of rebar a particular quantity. So that would basically group it up to different diameter settings, and what it will do is it will give you that range of diameters, and for this range it will give you the quantity. So that's really, really useful when you wish to, you know, apply, let's say, a particular rate probably for a particular diameter of rebar. Checking quantities. So there is this function which is really, really useful, where we get to, you know, see, oh, I love this actually, you know, it can reversely check the quantities from the model. The function is very powerful, so it gives the user the confidence of the calculations so performed. For instance, you know, if you would like to see the deductions, how did the deduction took place, or the tracing the quantities back in the model, so it takes you back to the model. It then shows you the deductions in details. You know, how did the relation between different elements are being, you know, considered in the software based on the rules of measurement, and different deductions or addition being made. Now that can be viewed in 3D. It's really, really useful for documentation purposes, or for presentation to the client, for instance, to the senior level. So that's really great. All right, so that brings me to the end of quantification process using TAS and TRB. Our software are built with these 3 core values. So we have got the intelligent functions, we've got the visualization, a good visualization, we've got the interconnected platform. So it speeds up your work efficiency, it improves your quality of you know, work. It you can share the BIM data within your organization or to different stakeholders. So this slide in particular shows how to deal with large projects which has got different blocks, for instance, or structure. So what we can do is we can actually split works into different teams. For instance, you've got different quantity takeoff teams, and once the quantification is done for the entire project in different blocks, then we can merge the entire project into one, and which would basically gives us direct quantities for each one of them. So this is how the merged model looks like. And what's so great about this is that you performed the work in a beautiful teamwork, and then you get all the data in one place by merging the project at a later stage. Okay, so here it has a comparison of traditional method using Cubicost software. So as an average from the different projects, we found out that the time consumption is much higher, which is 49 days by using manual method, versus the time consumption using Cubicost is 12.5 days. This is again the average from different projects that we considered. With Cubicost, we improved the functions to run checking quantities very faster, which is 10 times faster than the Excel quantities. So that's there, and then we have got similarly the accuracy of the quantities are again 98.8% than the Excel quantities. So this slide shows customers' most liked features that they found very helpful. So the functions like embedded with SMM, which is a measurement rule. So you've got the accuracy of measurements. You've got the report generation, for instance. You've got auto identification of elements. So different functionalities of features are there. So here's some really impressive works and feedbacks from our existing clients. They're constantly sharing their experiences using the software, which is really great. So finally, let's look at some case studies. So there are some of the projects done using the software in different locations across the globe. So we can see the efficiency improvement in percentage. So we've got 66.70%, we've got then 72.70%, 72.50%, and so on. Last but not least, so we've got the improvement or working efficiency. So I'm gonna share the top 5 reasons for which people chose Cubicost and why you should do it too. So we have got improving working efficiency, which is 60 to 70%, with high tech capacity and reputation, increase your chance to win tenders. To be your professional internal collaboration and management platform, that is Cubicost. You've got then make the team happy and higher feeling achievements, easy to communicate with the world's largest BMQS customer base. So these are the top 5 reasons why you should choose Cubicost. This is the part of my presentation for today. Thank you for listening. It was a pleasure spending time with you all.
Thank you, Mr. Samin, for that great presentation or that great overview of Cubicost. So as you can see, Cubicost can actually bring a lot of benefits to your company, including reduction in takeoff time, the fact that you can create 3D BIM models from 2D drawings, improving accuracy, productivity, and efficiency. I don't think there's any other software that actually has all of those built-in methods of measurement. And some of the really unique functions like view expression function or reversely check, where you can actually go to your BOQ and click on any quantity, and it would directly bring you back to the model and show you where those quantities came from. So software is really impressive, and I hope you can see the benefits that you can actually achieve from having it as part of your system. So lastly, here we have one last interview here, or one last talk from Mr. Xavier Wang from Gloden. So he's going to give us a brief overview into Cubicost TIO. So Cubicost TIO is basically an advanced feature of the Cubicost software that imports Rivet specifically. So let's have a closer look. Mr. Xavier, are you with us? Hello.
Okay. Hello, everyone. I'm Xavier Wong from Gloden, the General Manager. So to continue on our introduction of tasks, I'm going to further introduce a task version called task TIO. So it means take off intelligently with only one step. It can deal with not only 2D drawings, but also 3D models, including Revit file and IFC file. In my introduction, due to the time limitation, I'm going to quickly and briefly introduce what is TIO. So starting with why we need to use TIO, and secondly, I will introduce what is TIO, and lastly, what it can bring to you. So start with why we need to use TIO. I believe you have already noticed that no matter in the design stage, construction stage, or even maintenance stage, we are going to use BIM more common and more often. So we as a QS, to deal with all the costing things across the entire life cycle, to be able to use BIM model is very important to us. Thus, task TIO will become a very important tool for you. So what is TIO? TIO, that you can import Revit model into task software, and you can get all the quantity very easily, like we are showing now. And you can further do the check. So you can basically, so this version can support you to turn the Revit module into task model without any data loss. And why is it so special? Because task TIO is the only takeoff software that supports editing the model after you import the Revit file. And why do we need to import into task instead of directly doing things in Revit? The reason is here. Actually, there are several small or big issues in Revit. For example, overlapping, the wrong level, wrong layer, or even the wrong element type. So this will cause the inaccurate quantity result, so which caused the incorrect result and cost. However, if you import Revit into task TIO, the software can not only auto adjust some errors, it can also prompt the notification of potential errors. So you can fix all these issues very easily and get a very precise quantity. And how fast would it be? Because you directly reuse the model from Revit. So basically, when you have the model, you get the quantity. We take a project with such scale, for example, it can generate the quantity report with only 20 minutes. Imagine how fast it is. So let's further see what it can bring to you. If you are the developer, what it can bring to you is mainly three parts. The first one, you can get your cost plan very easily and faster. And secondly, you can deal with the design change very rapidly. So whenever there's a design change, you can modify your cost plan easily, because what you need to do to know about the new cost, the new quantity, is to import and get the report. And thirdly, you can also check with the downstream works. So this should be your workflow. You get the drawing from the designer and you import, or you get the Revit module. Let's take Revit model for example. You get the Revit file, you import into tasks, you get the quantity, you further get the cost plan. So around 20 minutes later, you get all the quantity, you further generate the cost plan quickly. You can also check this works with your consultant and contractor. And what if you are the contractor? For the contractor, the benefits are obvious. We as the contractor, we often deal with design changes or variation order. So whenever there's a design change, you simply get the new Revit file and you import and you get the new quantity. That's it. So simple. And there are some different scenarios for contractor. If you are the QS, the HQ QS, which means you are working in the office, and currently you are in the tender stage, you get the Revit model from the designer. You simply import the model into the software, and the software will give you the very precise quantity. You further generate the BQ. So this will help you to prepare the bidding documents, including your BQ, very quickly. And let's continue on the next stage. If you win the tender and you are going to entering the construction stage, you are going to coordinate with the BIM team. In the past, you need to work separately. It's hard for you to collaborate and coordinate. But since because you can reuse the model in tasks, so the design software and the costing software can reuse the BIM model. So in the past, you are separated work, but now you can collaborate with each other very easily. Another scenario, what if you are the site QS and you are currently in the construction stage, of course. What you can do is that you get the BIM model from your BIM team and you direct import the Revit file into task.tio. You get the quantity and you get all the cost. You can follow up all your cost. You can do the check very easily in the BIM model. And what if you are the QS consultant? The benefits is also obvious. The first one, of course, you can get the quantity and also the BQ fast, very, very fast. And secondly, you can deal with all kinds of design change very easily because you simply just import and get the quantity. And lastly, you can work within the entire life cycle because you simply just reuse the BIM model. So this is the difference. In the past, no matter what stage, you are dealing with the drawings, so you need to do your works all over again. But now you're dealing with the Revit file, the Revit module. What you need to do is to import the Revit model into task.tio and you get the quantity, further generate your cost plan, your BQ, and check your quantity easily and quickly. And even you are a BIM consultant, this software can also bring you extra benefits. This is your workflow. Originally, you generate the BIM model and pass to the client. But now, because you can simply import the model into task.tio and get all the quantity reports and even the BQ. So this can give you extra income from this business quickly, easily. So this is also what the software can bring to you. And no matter you are from a contractor, developer, consultant, etc., as long as you are the QS, or cost engineer or even a commercial manager, these are the benefits that the software can bring to you. First one, the faster cost plan. And secondly, of course, the faster quantity report and BQ. Third, you can rapidly deal with the design changes because everything is BIM based. What you need to do is to change the BIM model, or you simply import the new Revit file. And fourth, the fourth point, you can check downstream works. You can check each other very easily. And the fifth one, lifecycle BIM-based quantity management. As a QS, you can also use BIM model and make it easier for your works. And lastly, you can maximum the value of BIM model because you can reuse the BIM model. So let's recap again. With TaskTIO, what is the feature? It can 100% import the model, reuse the model with no data loss. Unlike IFC file, there's always data loss. But with TaskTIO, no data loss. And you can reuse the BIM model throughout the life cycle. So you can do your BIM-based cost management easily. And last, let's see the difference if you use TaskTIO and with the or compared with the traditional way. If you use TaskTIO for a project of such scale, you will spend only 20 minutes to get the quantity. However, with the traditional way, for one QS, it will take 4 weeks. This is the difference. So it's time for the BIM era. Also, this is the choice for us to make ourselves equipped with such capability to use BIM or not to use it. But I believe you are smart enough to choose. Let's embrace the BIM digital era together. This is my share. Thank you very much. Hope you like it.
Thank you very much, Davia, for showing that impressive feature of Cubicost, specifically Cubicost TIO. So we're close to the end of this webinar, but just before we wrap up, we've got a few things. We have a giveaway coming up, and also you know we're here to take some questions. So we'll have a short Q&A session for those who have any questions. But next, I'd just like to play a short video of some of the testimonials of our clients across the world, actually, that actually use the software, and just get a bit more feedback from these guys on the ground and how it's really impacted their company. So let's have a quick look.
My name is Lambert Gallardo. I work for Algana as a senior quantity surveyor.
Hi, I'm Carl Kevin Gallardo and working as QS here in Algana Group.
We've been using Cubicost for the past 3 years now, and it helps us a lot in quantity takeoff, and especially on a tendering stage.
Cubicost we started March 2018, I believe. Okay, and then we are using for the past 2 years, 2.5 years. The improvement in our estimation is like we are able to take out 2D and 3D estimations in a faster way, since it has auto capturing of the drawings from the AutoCAD and all these things.
I've been using this Cubicost since 2017, and it helps us save more time in getting more in quantities for architectural and structural.
There's a lot of features I like about Cubicost. It gives you fast result when calculating quantities. Another feature is that you can view the result by category. Like we can segregate it floor by floor, or you can do it by element wise. One more is viewing the drawing in a dynamic view. This helps you check the quantity, and this helps you check and ensure that all the things that you have drawn is as per the tender drawings.
The first thing will be the 3D reduction, which is more easier for the representation or presentation which can be done to the management or any other top level people. Then the second thing, the accuracy, and there is some allowances given default in the software which can be taken, like for a cover, reinforcement cover, all these things they are given by default in their setups, and which can be edited also. The third one, you have the BOQ integration, like when the quantities are automatically integrated with the BOQ, so that gives more easier way of computing or checking with the BOQ.
This software is give us 3D view of what we can what we are taking off, which help us easily understand and check missing items. Another thing is that it can detect if there is something wrong in your takeoff, which is it will not calculate unless you calculate first. Third thing is that this software you can attach finishes like tiles, plaster, and cladding, which is easier to understand.
I will definitely recommend Cubicost for one reason. All the projects here in Bahrain, a lot of projects here in Bahrain, is in lump sum contract. And for contractors, it's very important to check all the quantities. And during tendering stage. And for that, I think Cubicost is the best software that can help you. Thank you.
For sure, yes, we will recommend Cubicost. The thing is, the benefits of it, you will have a faster calculation and accuracy level, and the chances of rechecking how and what was computed. You can have the step-by-step things, calculations from the software, and the integration with the BOQ, directly into the BOQ. So it gives the best one for computation, estimation and all.
I would recommend this Cubicost because it is more efficient way in taking off quantities for both tender and post-contract projects.